created in a LIN bus is maximum only 64 because it has a identifier only six bits. Okay, and it uses two parity bit. What about CAN bus? What is the error identification? How it is done in CAN bus? Yesterday we saw.
Parity bus can be 1.5 or 2 in CAN
No,
bus.
no. Message, the error. What code? In RS232 we are using parity bit. In CAN bus we are using cyclic redundancy CRC code. Yesterday we saw.
CRT is something.
CRC. I'm
CRC.
writing here. You can see here. I'm writing CRC.
CRC.
Cyclic redundancy code. Because in exam, you may be asked to, I give a 4-byte data, say a 6-byte data, generate cyclic redundancy code. In exam 2 marks you can expect. Sorry, by mistake I told the question itself. Already question paper leaked by 2 marks. Okay, so you know that you have to add all the data bits byte by byte, 4 byte, correct, with the carry. Finally, you get a sum that should be inverted bit by bit inverted data once complement. Correct. That is what called checksum. That will be transmitted along with start frame, identifier, then data length, RTR bit, then actual data, followed by CRC, right, and other bits and the stop bit, that frame, right. So here also, here no CRC, here using 2-bit parity field. In RS232 we use single bit, here we are using 2-bit parity field, right. ID denotes the specific message address. Correct. What is this one? This ID specifies specific message address, but does not the destination. Like CAN bus is I say for example LIN bus, you have a master. It is connected to two, for example, 3 slaves: S1, S2, S3. Right? Master is transmitting ID. Say for example 1. Because you know that 0 to 64 can be number, it can vary. 64, 2 power 6 is 64. I say ID 0. Master is transmitting ID 0. Right? The data will go all these slaves. It will be received by all the slaves. But for example, this data, this is for example, it is meant, the data ID is meant for S3. Correct? Even though everybody is receiving, S3 alone will receive the data and store and will say that I received data, acknowledgement. Others will keep quiet. Because when data comes in LIN bus also, like a CAN bus, everybody will receive. If based on the ID, correct? If the S3 wants the ID, for example, this is for example, say door open, correct? ID 0 is door open, correct? The bus master is nothing but body electronics, ECU. This is master. This fellow is sending data to ABS. Correct. Please know that ABS always connect a LIN bus for you to understand and giving some example. Correct. ABS all this thing used by CAN bus, high speed bus. For understanding, I say that this is steering. Correct. This is engine. Again, don't say that again. That's what somebody may ask you. Sir, you said CAN bus is used for these 3 devices, ABS, all this. Now you are talking LIN bus for you. Understand I'm saying. CAN bus is asking door open. If door is open, what should happen? Engine issue should not start the engine. If door is open, right? Engine, if you press start button, engine should not start. Safety, right? So door open message will be sent by this master, which is LIN master. So I say that all the 4 devices are connected in the LIN bus only for understanding purpose. What will happen? It comes to means this data is meant for whom? Not for ABS, not for steering. It is meant for engine. ID 0 is sent by bus master, LIN bus master, who is nothing but body electronic ECU. Body electronic ECU. He sends this data ID 0 to all 3. ABS, steering, all those things, they are all connected LIN bus. What? Who wants this data? Engine ECU. Engine should not start the ECU, even if the press. So when the data goes, this fellow will give reply, yes, I received data. This slave. Now engine ECU is a slave. Please note that in this LIN bus, already predefined. The engine ECU, steering ECU, ABS, all these things can never be a master. What is the master slave communication? Only master can transmit data. Master can ask for the data. Only when master asks, slave should respond. The engine issue can never send data on his own. I'm sending data. Or ABS cannot send data. Steering control cannot send data. The reverse is not possible on the own. Whenever master asks, correct? Please see that many of the communication, all those things is a hierarchical structure, correct? Take your company, correct? In your company, CEO is there, correct? CEO can ask any detail from your next level, correct? GM, general manager. General manager will ask AGM. AGM will ask a production supervisor. Then the shop floor supervisor and the worker, correct? Worker cannot go and ask CEO, sir, do you need your data, correct? CEO comes to family, you cannot do the work. These are high. No, I'm not. See, do you understand certain things? Only when hierarchical, then see, things will go smoothly. Right? There is a structure way of doing things. So sometimes you need anybody can become master. Correct? Emergency situation. That's why CAN bus used for emergency what? Engine, steering, and ABS. These all safety related. Correct? When brake you apply, immediately engine ECU should respond, reducing fuel. Or engine fails, correct? Something happened, engine ECU. It was to send the data immediately to brake, apply brake. You take autonomous vehicle, steering and all those things. So this is a high speed. For that, that means any device can become master. That's why CAN bus is used wherever all the devices in CAN bus can become master anytime, provided the message what they have is highest priority. Another one thing also I told, do you remember? When you send the message in CAN bus, I told you there are 3 devices connected by a CAN bus, right? So 1, 2, 3. This has ID 0, this has ID 10, this has ID 20, correct? Message ID. Now, when nobody was transmitting data, this device 3 was transmitting ID 20. When nobody is transmitting, no competition, anybody can transmit. That is CAN bus advantage. So ID 20 was low, even the lowest priority. ID 3 was the device 3 was able to send the data in the CAN bus. While it was transmit data, you know that the frame consists of more than 128 bits. It was transmitting ID, all those things. Maybe some 60 bits it transferred. IDC or something like not complete. Suddenly, ABS, some driver pressed the ABS brake. What will happen? Immediately ABS will send his data ID 0. Then what will happen? This data will be stopped because this will have highest priority. Yeah, in CAN bus, another thing, whenever highest priority data comes, other data which if the data is lower priority, that data will be discarded because this fellow will transfer. That is the CAN bus beauty. Right? So you should not wait. You cannot wait for another some 60 milliseconds or this one because this is emergency. That's why you given highest priority for CAN signal. Correct? See, this you can these are detail you can read because CAN bus implementation you need to understand it. I give only basics. Correct? You have to study programming, all those things. You can see that. In case of this one, there's 2 parity. Here, in LIN bus, data is sent as a master slave. Master slave. Only whenever master asks for data, slave should send. Otherwise, you cannot send any data. Slave should just keep quiet only. He cannot volunteer. I am sending data, please receive. That's why I said, see, you cannot go to CEO, your company CEO, sir, I have data, I want to do this one. But generally, there's a provision. If you want some grievance is there, you can write to CEO, all those things. Can you just like go and enter the CEO room? Not possible. Correct? You need an appointment, all those things. But CEO can come and talk to you. If you see you come to your factory floor, you can talk to lowest grade employees also, worker also. Nobody can question, sir, why you are talking to me without my permission. That is called master slave. Come this one, correct? So that is meant for some places you need this kind of hierarchy. That's why the LIN bus is using this. Okay, then it consists of checksum. Correct? It can transfer how many bytes. This is the message ID. Correct? 2 power 6 is 64 different type of message can be created, but each message can have 8 bytes of data. Just like CAN bus, data can be 8 bytes. In your message, you can pack up to 8 byte data. That means different variable. It can be engine speed from the engine, this one, or door open. For example, LIN bus we are talking about boot open, that door open, each message, can have different message. Inside message, different data can be there. Up to 8-bit you can transfer. Okay. And it uses 8-bit checksum also. Okay. The master controls the sequencing message frame, which is fixed in a schedule. While designing LIN bus, what message, all these things should you have to discuss, correct? The master only controls how the message should be transmitted by all these things. We will see that how it is, which is called as scheduling, correct? There are several versions of LIN standards. Version 1.3 financed by the byte layer communication. You have version 2.0, 2.1 also with more feature. If you want to do this, you have to go and see this. There are different versions, correct? Like CAN 2.0 A, 2.0 B, CAN FD, latest one, which is 8 megabits. Whichever you want to see. CAN bus also, there are different versions. You have to look into what each version means. All this one, you have to look into that. Okay. Now we are coming here. What you call LIN bus? How you can see here. This is my bus master, LIN master node, which is going to transmit the data. So this is one frame. Okay. There are two parts in the one frame. One is called header. Other one is response. One is called header. Who is going to generate header? LIN master will generate the header. What header consists? You can see that in the header consists of, correct? Break bits. There are 14 bits. You can see that 14 bits of break. This is frame. Inside this is a total frame. In that first part is header, correct? Header will be first transmitted by the master. Master is going to transmit the header. Header consists of break 4 bits, then sync bits, 8 bits of sync, and the ID bits, message ID. This one it is 6 bits, correct? All the bits can be 0, 0, 0. All the bits can be 1, 1, 1, correct? 0, 0, 0, 1 to 1, 1, 1. Then you have 2 parity bits. Okay. Now, master is asking data. What is asking? Master wants this data. For example, ID 32, message ID 32, correct? Message ID 32 may be window, whether window mirror is down or up, correct? Then the slave device which is connected will send the data. This is the data, correct? Left window, right window, this one. For example, there are 4 windows on boot, correct? That means first message is whether the left door, front, I say the front to left door, front to right door, rear left door, rear right door, correct? Each byte is about, if that byte is 0, you know that the door is open. If it is 1, the bits 1, 1, 1 means like that, correct? So this data wants, correct? The master wants whether any window is open. Bus master, some device. So connected this one. It will ask that. So the window data is, the ID is 32. While designing LIN bus, you have decided window open and close data, ID is 32. Now what master will say? Master will send 32, correct? So master will put here 32 ID number. Please know that is here. Apart from that, your sync bits are there, other bits are there. Please note that lot of things are there, include this one. So master sends this. Now once this comes to slave, this is coming here to this device and this device and this device. 32, ID 32, this is ID 32. Right? So this is 1, 2, 3, 4. This is bus master. Master is asking for ID 32. Who has the ID 32? For example, device 4 has. Node 4 has the data. So these people will keep quiet. They will see this ID 32 because they are also listening. Because they don't have data. Because already is programmed. That's why designing the bus is not just like that. You have to sit together, discuss, and while designing, writing program for this LIN bus control of this one. Then, well, now this fellow has the data. What he will do? He will send the data back. That data is nothing but this. This is the data. He is sending this data along with checksum. This is for CRC. This is data. What data transmit checksum creator? Who is going to send this response? By the slave. Master will ask for the data. Slave will send this. Together it is called one lin frame. From this, what you understand? Can this fellow can send any data? Because each this devices, for example, series of data ID 20 to 25 is the different messages this fellow has. This fellow has ID 10 to 15. This has ID 0 to 10. Right? Now, master we says 32. Sorry, in this case, so okay, up to 32 or 35. So if master has 32, who can respond? Only this fellow has the data. Even though this, everybody will listen. What is job of the slave? Listen to what the master is asking. That is available here. This is a message. I want this message master is saying. Then immediately slave will start sending data along with set some data. Okay. So the master node loops through each slave node, sending the request information. Each slave responds to the data when it is polled. Master will ask this fellow. Okay, if this fellow is not responding, then this fellow. Then so whomever has data, they respond. Right? However, each node specification update, new feature has been added in specification, making it more complex. Lin bus transmits, Lin master transmits the header into the Lin bus. That's what I told you. Header is transmitted by the master. Okay. This triggers slave, which sends up to 8 bytes of data. I told you this is 64 bits, correct? That is 8 bytes. Maximum 8 bytes or 64 bits. Generally, in Lin bus, you need to transmit 2 bytes. 2 to 8 bytes. Minimum 2 bytes, maximum 8 bytes. That is nothing but 16 bits to 64 bits can be transmitted by in a message. Okay. The Lin bus is a polled bus. Correct? Polled bus means whenever master asks only, the slave should respond. Correct? Slave should not say, I have data. You cannot go and say, I have data, I have done this. Only your supervisor or manager asks what you have done. You should tell. You cannot go and say that every day, I have done this, I have done this. He says that, not you do your job, whenever I want, I will ask. Same thing only. Okay? A single master, one or more slave device. Master contains both the master task and slave task. Please note that master also will listen to the data like CAN bus. It can also become a slave. Correct? Master itself can become a slave because it also has a data. Each slave device contains only yes, slave task. Sorry. Communication with Lin bus is controlled entirely by master. I told you, master will ask data, slave should respond with that particular data along with checksum. The basic Lin bus is a frame, correct? This is called as a frame. The whole thing is called as a frame. Lin bus frame we are saying, which contains header and the response. Header is sent by the master, response is given by the slave. Together they are called as a Lin frame. The header is always transmitted by master node, consists of 3 distinct fields. One is called break field, sync field, and identifier. Correct? Again, I will show this. You can see here. Break field, sync field, and identifier. Of course, the parity also is there. There are 3. These 3 fields, they are called as fields. Field 1, 2, 3. Together, they are called as a header. This is sent by master. Slave consists of data, field, and checksum, CRC. Right? Checksum. Okay. The response, which is transmitted by slave, can reside in either master or slave, right? Consisting of data, payload, and checksum. Please note that the response can be, they said this one slave task. See the word what they are using. Whomever responds, the data is called a slave task. Correct? Master also can transmit data. Okay. Master asks for data. Sometimes that data may be available only with master. The data may be needed by other slaves also. Master feels this data should be sent to himself or somebody else also. So that's how it is done. Okay. Normally the master takes polls on each slave in a loop, correct? Using a header, breaks in sequences. Here, master will poll device, we call polling. Go to slave 1, slave 2, slave 3, it will ask one by one, correct? And when the data comes, he will take the data, take a decision. Prior to starting LIN frame, correct? Each slave device configured LIN bus. When you start your vehicle, correct? When you give the power, what will happen? Each node, correct? Which a master plus slave, they will publish data, correct? Which is also called substrate data in response to received from the header ID. When you start first time, they have to settle themselves, correct? Upon receiving a header, each slave tag verifies the ID parity and checks the ID to know whether it needs to publish. That's what I told you. I told you, sorry, this says ID 10 to 15. This concerns ID 20 to 28. This concerns ID, for example, I said up to 38. This has ID 0 to 9. Correct? This is bus master. You got it? But now, when the master asks for ID 18, correct? So that means this should be, I say that this is up to 90, ID 19. So if ID 19 is asked by master, who will respond? This fellow. Because he only has the data. This fellow, master also doesn't have the data. Correct? That's what we are talking here. So, and upon receiving header consists what? A data ID. Correct? The each slave tag verifies what are the data parity and checks the ID. Because ID, he said 30, what I said here, 18. Each fellow will check whether it has any of the data. Because each slave knows that they have this 10 data. ID 10, 11, 12, up to 19. This fellow has 20, 28, only 9 data. This fellow has again 9 data. Correct? This fellow has 10 data, IDs. So they verify whomever has data, he will respond. Okay. So if slave needs to publish data, sending data is called publishing. The word, correct? This is word terminology, LIN bus. Transmitter send the header, a master send the header, slave response. Response is called as publishing the data on the LIN bus. Okay. Which is called as publishing. Or subscribing, correct? They say that subscribing or publishing is nothing but sending the data based on the ID when the master asks for it. Okay, then checksum for error correction. Okay, for standard slave master communication, master broadcast the identified network, only slave will respond to payload. That's what it is. Master slave or slave master, right? Whenever master asks, then only slave should respond to data. Slave cannot send the data. I have data. You cannot transmit. There's no possibility at all. That is how the LIN bus is configured design. Master slave communication is accompanied by separate slave task in master load. This task self-receive the data published by the bus and respond to it. See, there are two things are there. Yeah, again, one more thing. One is called slave to master communication. Other one is master to slave communication. Correct? So, slave to master is possible only when master asks for it. Slave cannot send on his own. When master asks, he can send. The other one is called master to the slave, in which master slave, I told you master also is a slave. It will transmit data. It will also receive data. Correct? Sorry, it will transmit the header. Correct? But what is master job? I want this data. Header alone it will transmit. Master node will send, and if he has the data, he will respond with data. Correct? That's what I told you here. This fellow also has 10 different data IDs. Now, if master asks for ID 8, correct? Using header. Here, this is 8. That means what? First, the node 1 is a master. It says, I need data 8. Then all 4 nodes, correct? All 4 nodes will look and read this ID number. What is ID number? 8. So this fellow doesn't have, because he's a 10 to 8 year old. This fellow doesn't have, no, he won't respond. But master will see that he has the data, because he has list of data what is available. So this fellow will respond with data. Master itself will respond with data. Correct? There are 2 parts. Correct? Any questions?
So this last part, can you explain again? I'm sorry.
Yeah. See, the Linbus, master also is a slave. This is a master plus slave. These people are just slaves only. This is 2, this is 3, this is 4, this fellow is 1, master. Okay. If 2 types are there, one is called slave to master communication. Slave to master communication possible. That means the master, I told you, the master wants 18 data, ID 18. He asks this fellow whether you have 18. This fellow, what he has? He has 18. He responds. Correct? Instead of that, this fellow asks, then this fellow asks 22. What will ask? He will ask slave 1. This fellow say no. Then this fellow will send data, a request with a header alone. This is what the master is going to send. In the slave to master, slave to master data means master will ask data, slave will respond. Okay. The second one is master to slave, because master itself is a slave. Slave to master means master will send this data, ask for the data with a header, slave responds. In the other one, master to master will send the ask for data and he himself will respond because he has the data. First one is called slave to master. I'm talking about data motion. Data from slave to master. That means master will send the header, slave will give response only. That means these 3 people. Correct? Other one, if master says data, master send the communication header, he himself will respond data because he has the data. That is called a master to slave. Correct?
Sir, in the CAN frame network, master always master only. There will not be a slave role for the master right now. Sir.
No, because CAN bus data is who is transmitting data. Whomever is the bus master, he is going to transmit data. That is, it is called multi-master.
Okay.
After bus arbitration, yeah, good thing. Thank you. Because you are seriously watching. I am very happy. I want this. See, now we send 3 data, correct? So this ID is 0 because all the bits are 0, 0. We are talking about 3-bit ID, correct? This is 0, 0, 1. This is 0, 1, 0. This ID is 2. This ID field, correct? This is start frame, forget it. So this is ID equal to 1. This is ID equal to 0, right? So first all 3 are 0. They continue. They fight for each other. When next bit comes, second ID bit, this fellow is high. This is recessive bit. Automatically this fellow will go off because ID is big. Once a recessive bit, first whomever gets first a recessive bit 1 means that fellow is automatically removed from the he himself rescue. Okay, my data is low priority. He will not stop. He will stop transmitting. Nothing will transmit. Just become a listener. Then these 2 fellows are competing. Correct? Both are 0. Then it comes a third bit. This fellow is a recessive bit. So this fellow knows that this fellow has the lower priority, highest priority because the bit is 0. This fellow rescues. He won't transmit. Then this fellow become master.
Okay, sir. CAN frame is working, become time frame.
Then this fellow only going to transmit data also. Correct? CAN frame is a single frame. CAN is a single frame. Once you become a master, you try up to this. Correct? This is our arbitration field. Once you win the target, then you will transmit your data. Otherwise, you keep quiet. You just go back. And whomever is the master, he will transmit data. That data, if you want, you will save it. Data will be transmitted by the bus master only in CAN bus. In CAN LIN bus, bus master will ask for the data. The slave or master itself will become a slave and give the data back.
Understood, sir. Sir, then at the communication point of view, which one will be the faster, sir? Because here LIN request need to send, then slave has to respond. The response come back.
Okay.
In the CAN, it is a parallel communication, right?
No. Where CAN? It is also serial only, no?
Okay.
It is not serial. Thank you. I will explain. See, first all people will start sending master the startup bit, correct? Then arbitration data ID, correct? They were competing, correct? Once
Yes, sir.
This is best. This is the best. Yeah. Correct? They are fighting for who will control the bus arbitration field. Correct? 3-bit arbitration. Instead of 11-bit, I am showing only 3 bits for understanding purpose. Once this become master, these two will be this one. He is transferring digital data. Because they send bit by bit. This is serial communication. Please note that CAN, LIN, FluxRay, MOST, all are serial communication.
Okay, sir.
So the data also will send only after sending identification. If you win the bus, then you become bus smart transmit. In LIN bus, also it is not happening parallelly. Correct? In LIN bus also, with respect to time, this is time. Right? So here the arbitration, everything happens like this. Once you get the data is sent. So this is also serial communication. But here is master will ask data, slave will give data. Because please note that if data is available with master, it will become a slave. But initial, please note that there are two parts in CAN data frame. One is header. This is what comes first. Then data. First, this will be sent by master. After that, data will be sent by the slave. One after another. Then speed is concerned, number of bits transmitted per second is decided what is speed at the data is transmitted. Okay, LIN bus is very slow. I will show you that. We are going to discuss. Okay.
Okay, sir.
In LIN frame format, first bit is called break bit. Correct? Break bit. Every LIN frame begins with a break bit. It is like a start bit. We say SOIF. Start bit in RS-232, SOIF in the case of CAN. First bit. Correct? Here it is called break. But here it is not 1 bit. It is a 13 bit. Break bit is a long with this one 13 bits. In the start frame, SOF in CAN is a 1 bit only. In the RS-232, start bit is only 1 bit. But here it is 13 bit. Okay. Followed by a big delimiter 1 bit, which is a recessive bit. Correct? So recessive means this is 1, all it will be 0, 0. 13 bits will be there. You are going to send so many things. That consists of the break. That is, then you get the sync bit. Right? So this serves as a start of the frame. In CAN bus, 1 bit. In case of RS-232 also 1 start bit. In this LIN bus, it is around 13 plus 14 bits are used as a start. Correct? It is used as a start of the frame. Okay. Then next consists of sync bits. Sync field consists of second field transmitted master only. Who is transmitted? This is by master. This also by master. Correct? And then sync bit is defined by a character X55. Correct? So X55 means this is X means hexadecimal. Here X means hexadecimal. Anybody idea what is hexadecimal? Any idea?
To the P16.
Yeah. So in number system computer, remember one is called binary. Binary number system, you have 0 or 1. Correct? Yeah. A bit can become 0 or it become 1. Yeah. Okay. Next thing is byte. Byte consists of 8 bits. Correct? Then next one is called word. Already we talked 16 bits. like that long word, 32 bits. That's one thing. Next thing is number system, binary number, you have only two type of numbers, 1 or 0 or 1. Next one, we are using decimal system. In decimal system, you have 10 different type of symbols, correct? 0, 1, 2, up to 9. Okay. After that, what will become? Will become 10, 11. Correct? So you use 10 different symbols to designate a number. So in number system, by a decimal number system, we say what is called positional value. What is position value? For example, I write, okay. Anybody can say what is position value here? This is a decimal number.
So positional value of 5 is 1000.
That is 10 power
3.
3. This is 10 power 2. This is 10 power 1. This is 10 power 0. Anything to power this. So this is called ones position. It is called as ones position. Rightmost number digit is called one position. This is called a tens positions. If I say 0, there are 0 tens are there. Right? Tens position. This is hundreds position. How many hundreds are there? 8 into 100. So what I say, 8 into 10 power 2 is nothing but 8 into 100 is 800. Okay. This is called thousands position. Position value of this digit. Correct? The digit 0 or 1, 2, 3. Digit 0 is multiplied by 10 power 0. So if how will you find the total number? 5 into 1000 plus 8 into 100 plus 0 into 10 plus 1 into 1. Total is 5800, 0 plus 1, 5801. This I will find. Similarly, in case of binary numbers, 2 power 0, 2 power 1, 2 power 2, 2 power 3, it can go 2 power n. N can be infinity, correct? If I use n equal to 8, I say that 8-bit number, correct? For example, I have a 8-bit binary number 100100001. How to find the value? Can anybody say? What is this equivalent? This is the binary number, correct? Binary number is 0 or 1 only. This is bit 0, bit 1, bit 2, this is bit 7. What is decimal equivalent? How do you find?
2 raised to the power 1 first number के लिए
1 into 2 power 0.
0 हाँ 0
0. 10 power 0 in decimal number here 10 power 2 power 0. Okay. Plus
0 into 2 power
0 into 2 power 1. Correct? Then plus 0 into 2 power 2 plus 0 into 2 power 3. Then plus 1 into 2 power 4 plus this one 0 into 2 power 5. This one plus 0 into 2 power 6. This is plus 1 into 2 power 7. Okay. Now, what is this equal? You find out to 1. This means 1. This is 0. Correct? This is 0. This is 0. This is equal to 4. This is 0. This is 0. This is equal to how much? 128. Last one, 2 power 7 is nothing but 128. 128 into 1, this one. So total number is 128 plus 4 plus 0, plus 1. Correct? So it is going to be 133. This number represent decimal equivalent to is 133 decimal equivalent. Okay. This is called a binary number. Decimal number, you know, correct? Now, hexadecimal means you take a binary number. I have 8-bit binary number 1011 0110. This is 8-bit binary number, correct? This is B0, B1, this is B7. I divide the 8-bit into 2 nibbles. I told you 4 bits are called as a nibble, correct? Two nibbles. So this nibble, the 4 bits can be represented as a hexadecimal number. Hexadecimal number, what is the difference? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. In decimal system, it will become 1, 0. Correct? In hexadecimal, it will become A, capital A. That is nothing but 10. Decimal equal to 10. B is 11. C equal to 12. Decimal equivalent. But in hexadecimal, you will not write this. A, B, C, D, E, F. So how many numbers are there? 16 numbers. That's why you call hexadecimal. Right? You call hexadecimal number system. Okay. This is 0. This is nothing but 15. Decimal equal 1, 2, 3, 4. This is 10, 11, 12, 13, 14, 15. Okay. What is next number in this is hexa? Correct? This is decimal. What is next number? 1, 0. 1, 0. Then 1, 1, 1, 2, 1, 3. Then what is the next number? Last number? 1 F. Correct? 1 E, 1 F. What is next number? 2, 0. 2, 1. Like that, it go 2 F. Then 3, 0. So you can say that in hexadecimal, up to 16 numbers are starting with 0 to F. Okay. How will you get a very easy? If you have a binary, please note that in hexadecimal also, number can be hexadecimal number will convert to decimal binary number easily. Okay. So our binary number that now I have this binary number. How I convert to hexadecimal? Divide the byte into 2 parts. Correct? 4 bits. Then you can see that what is this? This is nothing but 2 plus 4, 6. Correct? Then what is this? 1 plus 2, 3. Correct? Plus 8. How much? 11. 11 how will you represent here? 11 is represent B. So the binary number 1011 0110 can be represented as B6. B6H. Are they right? XB6. This is notation used. If you see in a computer science book or a microprocessor programming, if you see B6H, don't get confused. The H is a hexadecimal. Correct? Or they put a small x before that. X, B, both are same only. That means hexadecimal number. But how will you know the binary number? Binary number will have 1 and 0 only. Any number, if you see something like this, you automatically know binary. Otherwise, they can put small b before. They put b, small b like this, but most of the time they don't put. You know that this is a binary number. Decimal number, you don't put anything. I know that this is a decimal number. No B, no H, no. So we automatically know it is this one. That's how it is done. Okay. It creates the master sends this character syncing. Correct? Sync character sent by the master. First to break, then sync field. Sync field is going to transfer what is that? 0101 0101. Correct? This is what it's going to transmit. Where? Please see here. 8 bits. Sync field is 8 bits. What is going to have? 0101 0101. This is what every time master will send. Sync field is sent like this only. Correct? Then this is the break frame. Then the ID, what data it want, what ID number? 0 to 64 or 63. Correct? ID can be whichever data it want, it will ask. Then the parity bit. This will be sent by the master. Okay? Then slave will respond. That's what we are saying. The sync field allows device to automatically deduct master is asking. So again, sync field is meant for what? The header, correct? Before giving header, sync field is sent. So the slave will be ready. Correct? Slave will be sleeping. Please note that in many times the electronics device can go to sleep mode. Sleep mode. Your cell phone, correct? Your screen goes sleep. Why? If screen is on, it takes more current. Your battery will drain quickly. most of the time it is in the pocket. Whenever you talk, only on the screen. So the cell phone, the microcontroller already programmed such that if you don't talk, this one don't press any button. After a few minutes, you can set the time. After 1 minute, 2 minutes, the screen will go off. CPU itself go to sleep mode. So that all electronic circuit will be sleeping inside yourself. So your battery comes for 3 days, 4 days. Similar to that, in CAN bus, LIN bus also, the ECU you can buy. Your car is working with the electric battery. Correct? You may think that milliamps current, nothing big in it. So you put your car, correct? By mistake, you did not switch off. No, engine is off, but you should not turn off the key, main key in your car or motorcycle. So all the ECUs are on. Correct? You went for 6 months vacation, 3 months vacation, parking your car. When you come back, your car will be totally drained. Because they make milliamps, but for 1 month, 2 months, if you don't want it. So that's why all the ECUs are, if there's no activity after some time, including CAN control, all these things, they go to sleep mode so that your battery is saved. Right? So they may be sleep also. Correct? To make it awake, I'm just giving an example. Correct? When master want to send, already vehicle is working, but is no color. So to see that device is ready, like calling hello. Correct? We would do that. So the ID field contains actual data. Correct? The ID field, the transmitter as the final field of the header by the master. This field identifies provides each message in the network and ultimately determine which node of the device should respond. Correct? This identifying ID field, which is 6-bit, decide which node has the data. That node will respond. That's what I'm saying. All slave talk continue listen to ID field. Please note that all these slaves, including master, will listen to the header. The header, correct? And finally, you'll see they sync themselves and see the header ID. And if the header ID is meant for it, if it has that data, it will transmit. That's what I'm saying. Then the slave will publish or subscribing. Publishing, subscribing is sending the data back to the master by the slave is called publishing in case of LIN bus. Particularly indicated. LIN bus provide up to maximum 64 days, already 0 to, and there are 64 possible because there are 6 bits. But please know that currently only you can transfer only 60 different IDs. Remaining 61s are used for some diagnostic ID, 62 used for future extension. You cannot create the ID number 60, 61, 62, all these things because they are all reserved. Okay, so 60 is reserved for future photograph something. The ID is transmitted to bus as one protector 1 byte with the 6 bits containing this one. That's how to do. The ID is sent by the master. Slave, if the ID data is available with slave will respond. Okay, so make this. This is the LIN frame, how it looks. You have the break frame. How many bits are break frame? 13 plus 1, right? 14 bits. Sync frame, 8 bits. Then data ID frame, 6 bits. Who is going to transmit this? Master. Please note this. In exam, you are expected all these things. Right? Show the frames. Okay. This is transmitted by the master. Correct? Please know that your frame starts from here. Correct? Then upon receiving, this is transmitted by master, slave will publish. What will publish? Data plus checksum. Together it is called as a one frame. Okay, this is one type. What is called slave to master frame. This is called as slave to master frame. Why slave to master frame? Slave has this data. Master had the data, sent it. Other one is master sent this. Correct? Header. Master has the data. They call master to slave. They called as master to slave. That's what I was explaining to you. Master to slave. Frame. Because master also is slave. Master has the data. Master itself, after receiving the ID, master knows he has the data, not others. He will give the data back. Then next thing is, this is one frame. Okay, this is the second frame. In between there's idle, correct? Interframe delay. Interframe delay. You cannot because master cannot just like immediately. He can. What I am saying is, with respect to time I am drawing the diagram, correct? This is t equal to 0, right? Master transmitted this, then slave responded. Immediately, this cannot be started. Master cannot start like this break. Next frame cannot be started. He has to give a gap, which is called interframe delay. This gap is a must, correct? So that the slave will be ready, confusion will not happen. This is how it works. Okay, so already I told you, lin bus is a polled bus. Polled bus means master will ask, hey, slave 1, you give me the data. He's not going to ask slave 1. He says, give me the data ID 22, ID number 21. Like that, you will ask this one polling. They call polling. And processing each frame to allocate a nominal time frame. Right? So it considers header, correct? Response, all these things. This is for more information. I'm not going to ask. Correct? For example, if you want, you can learn it. Okay. So again, last thing I want to show is, because many times already we saw, you have a lin bus, which is a slow speed bus. Lin bus is a slow speed bus. Data is traveled kilobits per second. Correct? Few tens of kilobits. But you have a high speed CAN bus. Correct? In your vehicle, please see that the figure itself shows that this is the vehicle, car. I took it from internet, it's not my diagram. So there's a low speed bus, lin bus, correct? What and all connected? Door lock, side mirror, turn indicator, correct? Window control. Each one is one lin node, one ECU. Right? These can be implemented in 8-bit microcontroller, $1, $2. I'm talking cost wise, correct? Slow speed is there. They are all connected by lin bus, correct? So one of that will be bus master, correct? Door ECU. This is the bus master. Door ECU, the bus master. Okay. So all the door lock, side mirror, turn indicator, each one is one ECU. This is also one ECU. Right? They are all connected by lin bus, slow speed, because you don't need high speed data. But sometimes they need, I told you, if door is open, correct? What is the engine? This is the engine, EMS, ABS, steering, right? You press the start. The engine should not start. How it knows? So the data from the lin bus will be transmitted to CAN bus also. There's a called as interface. In between interface can be there, right? The bus, lin bus master may be connected to the CAN bus. One side will connect to CAN bus, other side will connect to lin bus. This is called interface bus, right? This has both the capability. This door ECU should have lin bus provision, also the CAN bus. So through CAN bus, the data coming from door can be transmitted to engine ECU also, right? So that's what we are talking, right? So otherwise you can have like this also, separate interface ECU. Okay. I just wanted to quick this one note down. I'm going to not talk about other high speed buses, FluxRay, all those things. We don't have time. So yeah.
Sir, the 5 minutes break, can we have?
Yeah, that's why I said take this part. There's a break.
Okay.
Next, we are going to start the wireless communication next hour. So take this important point. You can take a break after 5 minutes or 10 minutes. We'll start the wireless communication.
Okay, sir. Okay. Thank you.
These are the significant points which need to be noted by you. So you can see the maximum speed only 20 kilobits, similar to RS-232. RS-232 19.6 or 36.8 something kilobits per second only. Lin bus also same, because door closing, opening, all this thing is not very fast, correct? They are very slow, not important also. It's not safety related. But before starting vehicle, safety related. But data need not transfer. It is this one. It can transmit 2 bits or 4 bits. This one, all those things you can note down. It works with 12 volt, because CAN bus, the data is transmitted to plus 2.5 volts to 3.75 or 1.25 with 2 volts difference. It was a differential bus, but this is not a differential bus. Okay, it works with 12 volt, and it supports sleep mode. I told you, wake up, all those things to save energy. Correct. See, once you are driving your vehicle, you are not going to open the way, this one, no door, all those things. Most of the time, this limb ECUs can be in sleep mode, so save power. Sorry. We'll meet after 5 minutes.
Okay, sir. Thank you, sir. We will back within 5 minutes. Sir, we can start now, sir. Hello? 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 Sir? Sir, we can start, sir. Sir, can you hear me, sir? Hello? Hello?
Sir, you are audible. We'll wait for Professor. Sir.
Okay, right. That is what I'm asking. Okay.
Yeah.
Okay. Huh? That is good.
Shall we start the class?
Yeah, yes, sir. Yes, sir. We can start.
Okay. I will close this. Just 1 minute. I will open the other file. Okay. Now we'll start the another important part of this course. What we call a vehicle to vehicle communication or vehicle to infrastructure communication. Okay, we'll see what it is. For that, the most widely used three different communication systems are Wi-Fi communication. You would have heard Wi-Fi used even in computer, cell phone, all those things. The other one is called Zigbee. The third one is called Bluetooth. These are three different type of communication system used in autonomous vehicle, meant for transmitting data between two vehicles, because you cannot use wired communication, correct? Because vehicles are moving, or from vehicle to infrastructure. For example, toll gate, correct? Toll gate, if you go, now you know that the tag, FASTag. FASTag is nothing but vehicle to infrastructure. Infrastructure, toll gate, where the money is collected, and your vehicle, there's a RF tag, correct? So between these two, there's a communication, correct? So that is Wi-Fi communication, correct? So your vehicle to infrastructure, you cannot use wired communication. So for that, you have to use only wireless communication. Okay. What is wireless communication? Wireless communication also called radio frequency communication. They also radio communication, wireless communication of actually they call radio communication because data is transmitted radio waves. But colloquially we call wireless because there's no physical wire. Because first we have wired communication, telegraph, all those things. Telephone invented by Graham Bell, then telegram invented much before that, maybe 150 years before, all those things. After that, we came to wireless communication, radio. Marconi, Chandra Bose, all these people invented the wireless communication radio, correct? Now that is used for cell phone, TV, everything wireless, including vehicle-to-vehicle communication. When we talk about wireless communication, the data is transmitted as a radio frequency, correct? We call a radio frequency spectrum. Radio frequency start from lowest range is called VLF, very low frequency, where the data is transmitted as a radio 3 kilohertz to 30 kilohertz. Okay, very low frequency, they call VLF communication. The maximum range data transmitter is VLF 100 to 10 to 100 kilometer only. Sorry, this is wavelength. Extremely sorry. This is called wavelength. The that depends upon wavelength of this one is called C by F. Okay, where wavelength of the radio, for example, if you take a sinusoidal wave, it has a positive cycle, negative cycle. This length is called as how long it takes, length, correct? Time, with respect to time, if you plot as at this one to travel from this one, the speed is different. The length of the wave depends upon the frequency, where this wavelength. Wavelength is generally mentioned as lambda, symbol, Greek lambda, equal to C by F, where C is nothing but speed of light. Okay, F is the frequency of the signal, frequency of the signal, a radio wave, frequency of signal or radio wave. Okay, for example, if I say that 3 kilohertz, correct? That is nothing but 3000 is 3 kilohertz. That F, this is nothing but F, right? What is this C? C is equal to 3 into 10 power 8. Speed of light, it is fixed. Is nothing but my lambda, correct? So you can see that this you can write 3 into 10 power 8 divided by 3 into 10 power 3. 3, this gone. This is 3 gone. So 1 into 10 power 5 meters, correct? That is the radio wavelength of the, if you are transmitting the radio signal 3 kilohertz or 3000 hertz, the wavelength of one cycle, this is one cycle period, the wavelength is nothing but 10 power 5 meters or 10 kilometers. The positive and negative cycle, the distance, if you measure the wavelength, will be 10 kilometers or 10,000 meters. Okay, so similarly you can calculate. The formula is simple, lambda equals C by F. F is going to be this number, C is constant, lambda you can always calculate. Okay, so then low frequency range, which is 30 to 300 kilohertz. Wavelength, you forget it, you can calculate. The next one is medium frequency MF, which is 300 kilohertz to 3 megahertz. Have you heard anywhere MF, medium frequency? Anybody? You have radio in your home? Radio, I'm talking radio, normal radio. Right? You have FM and AM. In AM, Chennai station, 720, correct? Kilohertz. Chennai is, correct? There is a medium wave. They call it MF means medium frequency, medium wave, AM, correct? Then you have SW, short wave, MW and SW, correct? So all this thing comes in this one. This is what radio communication is done generally. I am talking about radio, AM. Okay. Chennai station, Bangalore station, Delhi, BBC, all this. I am talking radio, not TV. Okay. There they are using. Then high frequency. High frequency means if the radio for 3 to 30 megahertz is called high frequency communication. VHF, 30 to 300 megahertz. Anybody, any idea where the VHF is used? Police, walkie-talkie, right? Police, walkie-talkie, police communication, all these things are done at VHF, 32 megahertz, this one. In this frequency, this is radio. you cannot transmit anything in this frequency. If you try to transmit, it is illegal. Correct? Then you have only it can use for defense, radio, all those things, VHF. Correct? Or short range within this one that can be used. The next one is ultra high frequency, which is 300 megahertz to 3 gigahertz. Then super SHF, super high frequency, is called 3 gigahertz to 30 gigahertz. And last one is EHF, extremely high frequency, 30 to 300 gigahertz. This is what the radio frequencies that who allotted this? FCC, Federal Communication Committee of USA. This will be accepted ISO, International Standard Organization accepted, but the rules are set by FCC. As I told you in the beginning, America control all electronic radio, all these things, because most of the inventions are done there. Apart from that, they are economic giant also. Militarily, they are strong. We have to listen. That's how it works. Okay, but of course, everybody accept. So, if anybody in world, correct, radio station I'm talking is there, it should be within this frequency only. Correct? There is one, or it can go up to 30, high frequency 30 to this one. This is used for police and defense, all those things. And then we have spectrum for FM. FM is, you know, that 88 to 108 megahertz. This is FM radio. Right? Like that is fixed. Okay, fine. That is to just, you know, this picture gives an idea. Okay, already that's whatever I explained is here. Radio frequency AM 600 to 1.6 megahertz, FM radio 88 megahertz, this one, and mobile phone. Please see the mobile phone 900 to 2.4 gigahertz only. All your mobile, you know, the Zio or BSNL, whichever world, Vodafone, they have to use only this. Because we call it a spectrum. No, government is selling the in particular band frequency only. Mobile phone should operate. You cannot operate a mobile phone in this or in this. All this thing not allowed. TV broadcasting 54 to 700 megahertz. Wireless communication, right? 2.4 gigahertz, right? Then ultra, so micro and all this thing that is not needed. Radars are used already. We know that radar we have used, correct? It is in the gigahertz. Already we saw. Fine. Now, when we talk about wireless communication, there are two things are there. One is called transmitting device. Other one is called receiving device. Right? So there physically there's no wire. Data from transmitter is transmitted wirelessly. This symbol is used as a wireless symbol. If I show this, this is called wireless symbol. Data is transmitted wirelessly without wire. Radio communication. Okay. So you need that wire. So wireless communication used for cell phones, between laptops and internet. All these things are using wireless, including all cell phone or everything. Okay. If I want to transmit some information, correct, please take the function. This is called functional block diagram radio. Correct. Information available here. It may be a microphone. I'm talking in my microphone. Correct. From microphone, the sound wave is converted to electrical signal that is goes into the source, in which it is converted into appropriate signal. Because here the signal in the order of millivolts. Microphone, my sound wave is converted to electrical signal under millivolts, 0 to 100 millivolts something. That will be go to source coding, and then it will be converted into what you call channel encoding. Then finally it will be modulated, and then it is connected to antenna. This is called as, this is symbol for antenna. This is called transmitting antenna. Okay. Then from here, this is transmitted. This is called radio waves. From antenna, transmitting antenna, radio waves are traveling, right? And it comes and hits the receiving antenna. This is receiving antenna. This received data will be demodulated, and finally some decoding will be done. Finally, source coding, and this information comes. It can go to a screen if it is a TV, or it can be a speaker if it is a radio, right? If it is a cell phone, a screen plus speaker, right? In cell phone, you have both. You are listening and also seeing, right? So that is so data is transmitted by the transmitter using transmitting antenna. The radio signal travels. Please note the radio signal can travel in the space also, where there's no air. Correct. That's why you are able to transmit, communicate with the Chandrayaan, Mangalyaan, or rocket, all those things. Correct. Satellites. Everything is using radio communication. Sorry. Okay. So next, when we talk about the radio communication, I told you we talked about the data before transmitting. Correct. Before transmitting this one, it should be modulated, and after receiving, this is receiving antenna. This has to be demodulated. Modulation, demodulation. The data will be modulated at the transmitter, transmitted wirelessly. Once it received by receiving antenna, at receiver, inside your cell phone, inside your radio, inside your TV. This is the TV station or cell phone station. In cell phone, now no station, your cell phone is a transmitter and receiver, right? But in case of TV, radio, TV station is the radio station, which is called broadcasting, right? Where somebody go and sing, dance in the TV studio or radio station, that the information will be converted into electrical signal using a microphone or TV camera. Then that will be modulated and transmitted and received under the receiver. Correct? In your TV or your cell phone or your radio, the data will be demodulated and final data will be shown in screen or speaker. Okay. When we talk about modulation, there are two types of modulation. One is called analog modulation. Other one is called digital modulation. Okay. In the analog modulation, there are three types. Amplitude modulation, which is called as AM, and frequency modulation, FM. This is what I told you. Radio station is the AM radio station. Correct? Chennai AM is there. 720 kilohertz. Correct? It is transmitting. And FM is there. Correct? FM station. Correct? Radio Mirchi. So many stations are there. There they use frequency modulation. Then third type of modulation which is called as PM, phase shift modulation or phase modulation. This is for transmitting analog signal. Analog signal means continuous signal. Any signal with respect to time. This is voltage. This is time. If signal is changing with respect to time, it is called analog signal or continuous signal. Right? Digital means convert this into binary number, zeros and one. Each value take this value is converted into a 8-bit binary number. This amplitude is converted to 8-bit binary number. This amplitude converted to another 8-bit number. Correct? This is called as digitization. Correct? Continuous signal may be converted to binary number. Each instant can be converted to binary number, and then that is called digital. After that, this data binary number can be modulated. There are three types of modulation there: amplitude shift keying, frequency shift keying, and phase shift keying. Same as this. Right? It can be digital modulation, in which the binary data 0101, this bit I wanted to transmit. In CAN bus, all those things we send as 0 volts or 12 volts, correct? Or 5 volts or 2.5 as wires. Here we have to transmit this one. So this need to be modulated. If you want to transmit the data wirelessly, the data, binary data, should be converted to the radio signal. Before that, you have to do digital modulation. The three type digital modulation is there. Okay. So if we talk about analog modulation, in analog modulation, this is a signal I wanted to transmit. Right? This is a signal I want to transmit. It may be a microphone I'm talking. This is my voice signal. Correct? Which is converted to electrical by a microphone. This signal you want to transmit to receiver. So you cannot directly transmit. You have to use another signal called carrier signal. Right? So both will be given to modulator, analog modulator. This is a device. If you give this, it will generate, this is called modulator signal. This is called amplitude modulator signal. Please see that this is a carrier. Carrier is a constant. For example, this is plus 5 volts, minus 5 volt. This carrier signal, a particular frequency. I say that Chennai station AM, what is 720 kilohertz? So the frequency of this signal will be 720 kilohertz. They call carrier signal. That is given as a one input to the modulator. The modulator will be in the radio station. It is an electronic device. And this is your through microphone, your voice signal converter. Both are given. finally you will get this signal. This is called amplitude modulated signal. This will be given to an antenna, right? Radio station antenna, right? Radio station antenna, which is called a transmitting antenna. So this transmit data. So this radio signal, which one? This modulator signal. This will be received by signal be received by radio, by your transistor radio or this one, or in car radio. Then it will be, you will get back this. Getting back again from this, getting back this signal is called a demodulation. This is called as modulation. This is given to demodulator. And from this, the original signal, which this signal is got, correct? This is at the receiver. So in between, you have radio signal, radio frequency signal. This signal is nothing but transmitted wirelessly. Okay. So I told you there are two types of modulation, very popular. One is called amplitude modulation. Instead of this, this carrier frequency itself modulated. You can see that the frequency of this is the input signal, and if it is FM, carrier will be given. This is given. This signal will generate. You can see the carrier frequencies will vary. This is called FM, frequency modulated carrier. This will be transmitted in AM station. This will be transmitted in FM station. This will be transmitted. How you are generating? You need a modulator. What is the input to modulator? Your signal you want to transmit along with carrier. Two signal given. You may get this signal or this signal. This is FM station. This is AM station. Correct? Already said. Okay. So then third one is called phase shift modulation. You don't worry about how it look. I just for the understanding, I'm saying what are three different type of modulation is I'm showing. This is the amplitude modulated signal. This is FM signal, the PM signal. You can see here, this is the carrier. This is the signal which I want to modulate. If I modulate, I may get, by giving to this one, I can get this, or can get this, or get this. These are three types of communication system. Okay. This is for analog communication. Different type. Please, the signal is varying continuously, right? So this is called analog signal. Next one is called digital, different modulation technique, radio communication, digital signal. So I want to transmit a binary data. Correct? In CAN bus, we know our data said this is 1, this is 0, and 1. The 3-bit info I want to transmit. So this is the data I wanted to transmit wirelessly. What I do, I send it to my FSK, frequency modulation. This binary data is given as input, and I give a carrier. This is carrier. This is my binary data. So what I get is I will get this. This is the FSK, frequency shift modulation. FSK, frequency keying. Okay. So then this will be transmitted using an antenna, right? Wirelessly, it will be transmitted. This signal will be transmitted by this one. At the receiving side, again you can get back the original signal. Okay, this is how it works. Just note down, because this is just for your understanding only. Correct? So binary data, correct? And this is the carrier. This is the actual data I want, 0, 1. It is converted into binary voltage level. Correct? 0 volts or 5 volts. This will be given as one input. Other one is a carrier. You may get this 3 types of this one. No doubt, there are 3 types. ASK, amplitude shift modeling, frequency shift keying, third one, phase shift keying. These are the 3 different types of digital data communication. Correct? You should know at least names. How it works, you can understand more. But I told you how it works basically. Any doubts in this?
Sir, how the carrier wave and digital signal are combined and sent?
That is a modulator circuit. The electronic circuit is there. They call modulator circuit. Because we can discuss that is separated pure electronics. Many of you may not understand. It is called a modulator, and a circuit is there, for which I give both the signal, this signal and this signal. It will generate this. If it is amplitude shift keying, it will generate this signal. If it is a FSK modulator, it will generate this signal. If it is a PSK, frequency unit, it will generate. definitely one of this only, you will not use both. Any one of this you may use in your system. And then this will be given to an antenna. This converter signal that will be broadcasted. And receiver side reverse will happen. Demodulation will happen. So that you will get back to original data, detailed data. Okay, coming back to wireless communication. I told you AM, FM. This is used for radio stations, TV stations, and also for your cell phones. Cell phone communication, radio station, and wireless communication by police or any wireless communication or military. All these things they use this only. The old technique. Nowadays, slowly everything become digital, correct? But still radio, FM, all those things are using only analog communication. But when we talk about radio communication, we use cellular cell phone and WiMAX. This is for radio, for cell phones. Okay. Then license-free digital communication, Zigbee, Wi-Fi, Bluetooth, Z-Wave. These are used in wireless communication, short range. These are meant for short range communication, digital communication. Please note that Zigbee, Wi-Fi, Bluetooth. This is what we are going to see today and in the next class also. Okay, this is what we are using. These are wireless communication. They are called wireless digital communication. Why? Using this, we are going to transmit binary data. Right? Binary data 0, 1, 0. This data I convert into radio waves using this. This is my data. Right? That again, please note down this, very important. This is data that is converted to the voltage level. This is for you. On paper you are writing, but electron test circuit under only voltage. Right? 0 volts. This is 5 volts. I said 0 volt, 5 volt. Right? The bits are converted into 0 and 5 volts. That is given as one input. Other one is a carrier. So depending upon this, it generates this radius. This one that will be connected to antenna. Please note that you may not use all three. Any one of this you will use for transmitting data. Correct? In case of Zigbee, Wi-Fi, Bluetooth, you will use FSK or ASK, FSK, PSK for final transmission. Which one use? The company decides. Right? You are buying a Wi-Fi, Bluetooth device. The company decides which manufacturer, what type of the modulation it has to use. Okay, so these are this one. Otherwise, this is used for LAN. Wireless Wi-Fi is used for Ethernet inside your vehicle, computer to computer, right? Computer to computer communication. Wi-Fi communication inside your car, this one you use this. Then remote communication, you use micro DSL. This is where cell phone, all those things. Our interest will be talking these three only. Okay. Zigbee, Wi-Fi, Bluetooth. Okay. Again, what is the advantage of wireless? Please take the notes, important points. What is the wireless? This one, it is quick installation, right? I want to talk to, because there's no fixed this. In case of wired communication, if there are two telephones, right? For my room, I have a phone. My lab also you visited, right? Between you, there is a wire is already laid, right? And the phone is fixed here on my table. My lab also phone is there. You cannot move this just like that. Right? So you have to rewire everything. So, but in case of cell phone, I have my cell phone sitting in my room. My student is sitting in another room. I talk with him. Instead of that, I go to another room. I talk to him. Correct? So there's no specific installation. That is one of the advantage. Wireless advantage is if you have two wireless devices, you can talk with each other from, as long as it is within the range, you can use it. In wired communication, which is not possible. And wireless communication is low cost because no wires are needed, no installation, no specific this one. My cell phone is in my pocket. Your cell phone is, we can talk, right? So that cost is less. Continue work during power outage also, because many times it can be battery operated. Most of the wireless communication, correct? Cell phones are, but of course you need cell phone tower, you need power, but between two cell phones, they have built-in batteries, correct? So as long as battery is available, 1 day, 2 days, you can talk if the cell phone tower is working. Of course, you need a battery backup there, but that is advantage. Flexibility, right? You multiple. You can see that 2 people can talk. Then we say that you can add third person also. No, when you are talking with a cell phone, you can add 1 or 2 or 3 more people. Conference call, correct? You can do conference call while you are talking. I am talking with you. Suddenly, if somebody want, you can add him as this one. Again, you can disconnect. Correct? That is possible. But in telephone, regular telephone, you cannot do that. Only 2. Suddenly, you cannot change. You need wires also. These are the main advantage of wireless communication. Right? But what are things you needed? You need RF spectrum. Correct? You need to transmit particular frequency only with government permission. Correct? You cannot transmit data while you cannot create your own device, transmit in any frequency. That's what I told you beginning. Please note down, the spectrum is fixed, right? For each this one, radio communication, I told you medium frequency, radio station can transmit. FM is 88 to, already it is here. You can see here, FM radio station, 88 only. AM is only this. Mobile phone me only this frequency you can transmit. You cannot transmit any other frequency. This is the limitation, right? Of the wireless communication, including Bluetooth also. You need there are some band which is called unlicensed. For that, if you want to transmit anything, you have to pay money to government, right? You know that spectrum allocation or government generally sell the spectrum. Geo by 50,000 crore, 1 lakh crore for 10 years they can use something like that. So that means only that company can transmit the frequency. Geo bought the Chennai, for example, the spectrum is a 5 gigahertz. In the Chennai, only they can broadcast the cell phone using the 5 gigahertz. Other company cannot because they did not buy. The government given permission for the only Geo. BSNL in some other city like that. It is a paid one, right? RF communication, the company has to pay. Of course, you are also paying. When you are talking, per minute you are paying 1 rupee, 2 rupee. From that, the cell phone company pays to government. But there are some unlicensed which can be used emergency purpose for a very short range, 1 kilometer, 2 kilometer. The unlicensed band. That is one thing. Then while talking about wireless communication, 4 things are important. Coverage. For example, in wireless communication, there's a transmitter. It sends the data through wirelessly. These are receivers. Right? So one transmitter, multiple receivers can be. For example, radio station, Chennai radio station, FM, correct, transmits, or Chennai radio station, only one station, there may be 1 lakh people listening in the cell phone or radio. 1 million people may be listening. Okay? Multiple user, that is advantage. Right? Using one device, you can communicate to millions of people. That is another advantage of wireless communication. If you need public broadcasting or one-to-one also, secret communication. Cell phone is secret communication, correct? Between you and the other person only. Others, even the other cell phones are receiving my data, and they cannot listen because I am talking specifically calling to particular number. It can be public broadcasting or one-to-one correspondence, correct? Confidential also possible in radio communication. The coverage means what is the distance if I transmit from this device, what is the distance it can cover. For example, you talk about a cell phone, correct? So if tower is nearby, another signal maybe 1 or 2 kilometers or 1 or 2. This is its cell phone tower, right? This is my cell phone, my phone, correct? And this is your phone. Because both are in same place. But when I call you, what happens? From my cell phone, the signal goes to the cell phone tower. It trends to here. This is how it works. I cannot directly talk with you, even you are next to me. Correct? In cell phone and wireless communication, the cell phone, this is one cell phone, this is another fellow. Correct? So I send my signal to the cell phone tower, which again retransmit to you. When you talk, it comes to here, it comes here. What is the distance I can? That is called coverage distance. Correct? It can be 1 kilometer, 2 kilometer, 100 kilometer, 1000 kilometer. That depends upon transmitter power. How much is the power of the transmitter? The power is measured in kilowatt or megawatt. Okay. So then wireless communication, point-to-point communication or point to multi-point. Radio is point to multiply. One station, there may be 1 million radio people listening, but point-to-point cell phone, correct? I am talking with you. I can talk only with others cannot listen. Not possible. I stop here. Tomorrow we'll continue with. So these are the advantages of wireless communication. Then we'll start talking about the three tomorrow. We'll talk about Zigbee, right? What is Zigbee how it works? Bluetooth communication. Then we are going to talk about Wi-Fi. Then advantage of Wi-Fi, all these things. Tomorrow we'll complete wireless. Next week we will talk about path planning. Okay. Thank you. Give your attendance without fail. Have a nice.
Sir, still how many classes are left, sir? I mean, for the we require the cutoff this one, so that's why I'm asking.
Which one?
Sir, still how many chapters and classes are left? Because
Next week we have 3 classes.
Okay.
Then tomorrow we have class. I will complete the wireless. Next week we will start with wireless tomorrow and then path planning. We have another 4. Tomorrow one, after that 3 more classes next week.
Okay.
So 2 chapters. Wireless already we have started. After
Okay.
that, path planning. Okay.
Okay, sir. Thank you very much. Thank you.
See you tomorrow. Take care.
Thank you, sir. Okay.
Shall I close? Attendance given everybody?
Sir, given, sir. Already in the chat box.
Okay. Thank you. Take care. See you tomorrow 5.
Thank you, sir.